Hi everyone. In this last video for section 1.1, we're going to be looking at some phrases in English and the mathematical operations that correspond to them. So I'm going to list out the four main operations that we work with and some notation and phrases that go along with them. Here we have addition, and we write that as A with a plus symbol B. And some phrases that mean addition would be all of the phrases in the phrase column. So A plus B, the sum of A and B, A increased by B, B more than A, the total of A and B added to A. For subtraction, denoted here with an A, a dash, and a B, the phrases that mean subtraction are A minus B, and that's typically how we read that expression in the middle, the difference of A and B, A decreased by B, B less than A, and B subtracted from A. For multiplication, we actually have a lot of different ways of writing it down, but very few ways of saying it. So all of these notations mean multiplication. We have the X, or the standard times symbol, the dot, which also represents multiplication. The asterisk, if you're typing on the computer, usually represents multiplication. You can write AB to represent multiplication, and obviously you can put parentheses in there to imply multiplication as well. But as far as the phrases go, we have A times B and the product of A and B. For division, we have A divided by B, or the quotient of A and B, or the ratio of A and B, or B divided into A. And there's basically three ways we're going to be writing it in this class. The first one with the division symbol, or A/B, or what you'll most likely see a lot of is as a fraction. So let's put into practice translating these phrases from English into mathematical expressions. The difference of 14x squared and 13. Now, in this phrase, we're going to be focusing on this word right here as the difference of A and B. And if we go back and reference the phrases with our A's and B's, you'll see that 14x squared here is playing the part of A in that phrase, and 13 is playing the part of B. So, translated into a mathematical expression, we have 14x squared minus 13. Next, we have the quotient of 2x and 2. And here, the key word that we're going to highlight is the quotient, which we know refers to division. And so again, this 2x is playing the part of A, and this 2 is playing the part of B. So a way to write this would be 2x over 2, or any of those other ways that we showed on the earlier screen. 13 more than Z. Here, we have the phrase more than, which is supposed to mean addition. And actually, the order doesn't really matter so much here for addition, but technically, if you look back earlier, we have that the first number is playing the part of B, and the second number is playing the part of A. So 13 more than Z would be written as 13 plus z. All right, the sum of 17y squared and 19. So this one is pretty literal. The sum means addition. We have 17y squared being A and 19 being B. So what we have is 17y squared plus 19. Eight times the sum of x and y. Now, we want to be a little bit careful here because we have actually two operations that are being combined. So we have 8 times the sum of x and y. Let's write down what we know. So we have 8 times would be that part. The sum of x and y would be x plus y. But we have to be careful because this sentence implies that we are taking 8 times the sum of x and y, not times just one of these, but rather both of them. So what we need to do is include parentheses around the x plus y. And lastly, we have the sum of 8 times x and y. So this is similar to the information we have in number 5, except the order of the phrase is different. So we're taking the sum of 8 times x and y. So 8 times x would be 8x, and we're taking the sum with y. One thing that you should focus on is the difference between these two expressions and the difference in the phrasing, because this can trip you up. So when you mix operations like this, it gets kind of tricky, and you really have to be very particular about the order in which you say things. Because it's very easy, for example, to say 8 times x plus y, meaning 8 times the sum of x plus y, when you really mean the sum of 8x and y. So be careful. All right, now these examples are pretty much living in a vacuum, right? These aren't real world things. I mean, they're English phrases, but they're not complete. So let's look at some applications, which is to say word problems. I know, you probably got upset just at the mention. The length of a rectangle is 14 less than the width. Let W represent the width of the rectangle. Write an expression for the area of the rectangle. So first of all, we have W representing the width of the rectangle. We need to represent the length with something. Maybe we can call the length, well, if we're not so creative, we can just call it L. So if we call the length of the rectangle L, we're saying that the length of a rectangle is. So the word is generally means equals. So here's what we have so far. L equals 14 less than the width. So if we go back to our phrasing for subtraction, you'll see that this is subtraction. Although this guy is playing the part of B, and this guy is playing the part of A. So we're taking the width and we're making it 14 less, which is to say that we are taking W and we are subtracting 14. So the length is W minus 14. But if you continue reading, that's not the question we were asked to answer. We were asked to write an expression for the area of the rectangle. It has maybe been a while, but the area of a rectangle is always the length times the width. And if we know that the area is length times width, and we know L is W minus 14, we can actually write the area replacing the L, the W minus 14, to get W minus 14 times W. And that is what we were being asked to answer. Now for another example, we have someone with dimes and quarters in a bag. So it doesn't really matter what the person's name is. I'm gonna just pull a random name. Let's see here. First name only, gender either, and maybe we want to know more about this person. Okay, so the name that we got is Elias. He's 34. Let's see, blood type A+, death date October 26, 2075. So, good job on that, Elias. All right, so let's go ahead and fix that. All right, now Elias has dimes and quarters in his bag, and the number of dimes is 7 less than 4 times the number of quarters. Let Q represent the number of quarters, write an expression for the number of dimes. So it seems kind of intimidating because there's a lot of text here, but let's break it down. We have dimes and quarters. The number of dimes is 7 less than 4 times the number of quarters. And Q is representing the number of quarters. We also need to figure out what represents the number of dimes. Since I'm not feeling so creative, we're going to call that number D. So D represents the number of dimes, and Q represents the number of quarters. And according to this information here, the number of dimes, D, is 7 less than 4 times the number of quarters. Remember that the word is means equals, so D equals 7 less than 4 times the number of quarters. So again, we're mixing operations. But basically, we have 4 times the number of quarters, and we're making that 7 less. So that would be 4q minus 7. And yeah, that's what we're being asked to find. And that's it for section 1.1.